Hello, welcome to the recording of exponential functions, to the video of exponential functions. Okay, that's what we're going to talk about here. And I'm going to do this in really short videos so that you can see what an exponential function is. So first, we have an exponential function is a function of the form f of x equals a to the x. So it's going to look like this. Now, the most common exponential function is f of x I'm going to shoot that down a little bit, is f of x is if we have the base e to the x. That is the most common. Now, e is a special mathematical character, and we'll talk about what its exact number is later. These are the graphs of a to the x and the properties of a to the x. And then you see that we have, a to the negative x and the properties of a to the negative x. So now, here is e. So this is what e is. E is a special number right here, and it is a limit. And we'll talk more about this when you get to your next course, or you'll see it at different stages. And so this is what it's the limit as x approaches infinity of 1 plus 1 over x raised to the x, and that's e, and it's a special number. It's kind of like pi in math, so it's non-repeating, non-terminating decimal, and so it's kind of a special number that we use in math, okay? And so when I do anything else that I do in math or in this course, we're going to be talking about e's. All right, and so what I'm going to expect you to know is I'm going to expect you to know the graph of e to the x, and I'm going to call this the graph of g of x equals e to the negative x. So we're going to look at these, and this is all I expect. Here's x, here's y, and so here's one of them. Here's the other. Yikes. And this point right here should be on the y-axis, is the point 0, 1. And why is it 0, 1? Anything to the 0 power is 1. All right? So this is the graph of f of x equals e to the x, and this is the graph of g of x equals e to the negative x. And so those are the graphs that I expect you to know. You can move them up, you can move them down, whatever. This right here, the x-axis, is an asymptote. All right, and so that's the one I expect you to know. Okay, and so those are the graphs I expect you to know. Now, you need just general knowledge. You need to know these functions right here. You need to know these. All right? Okay, those are what I expect you to know. All right, you need to know that for the compound interest, this is compound interest. All right, that is the formula for compound interest. And this is the formula for continuous interest. All right, and those formulas I expect you to know. All right, now let's get on. So, this file was supposed to be updated. So here are some examples. So we're just going to look through these. So you want to graph this function. The shape is going to be the same, and all we're doing is for all the y values, we're going to be moving it up 1. So that means that if I put in 0, so look at this. If I have f of 0, then I'm going to have 2 to the 0 plus 1, so that's 1 plus 1. So that's 2. So now my asymptote is going to be at y equals to 1. So it's going to look like this. Okay, so here's my x-axis, right? And here's my y-axis. And this point right here is now going to be 0, 2. And this is what f of x is going to look like. So it's just going to move the whole graph up, and you can't see my hands. I'm doing it like I would be teaching. It's going to move the whole graph up one value. So it's going to move it up, the whole graph, up one y value. That's it. That's all it's going to do. All right? Now, let's talk about this one. So let's look at what's going to happen if I put in 0. So if I put in 0, I've got g of 0 is going to be 4 to the 0 minus 5 plus 5. Well, that's going to make that negative 4. What value do I need to put into the exponent? So what value of x will make x minus 5 equal to 0? Well, the answer to that is if x equals 5. Right? So if I have g of 5, then I get that I have 4 to the 0 plus 5, which equals 1 plus 5 equals 6. So what that means is that right here at x equals to 5 is where, so here's my x-axis. So, I'm sorry, here's my y-axis. So my normal function, so this is a to the x, and it goes through this point 0, 1, right? That's my normal function. But now this function that I'm looking at, this function right here, is going to go over, and it's going to go through, it's going to be up here, and it's going to have its asymptote is going to be y equals 5, and it's going to look like this, and that's going to be g, because at x equals 5 is what's going to make that value 0. This is the same thing as the x plus h as shifting a parabola. That's what we're doing, is we're shifting this graph, and we're making it like we would shift a parabola. That's all we're doing. All right. So now let's talk about e to the negative x. So all this does is it reverses it. So here's x, here's y, and I'm going to shift it, and I'm going to reverse it. So here is h, and this still is the point 0, 1. Okay? So all it does is flip it around. So the normal curve looks like this, and this is y equals e to the x, and now I'm just doing a mirror image of it. So on one day a child deposited, so I'm going to use, because it tells me I'm compounded continuously, I'm going to use PERT. So that's A equals P e to the RT, PERT. And I want to know on the 25th birthday. So P, the amount I deposit, is 40,000. My interest rate is 0.06, and my T is 25. Okay? And so I just put it in there. So A equals 40 times e to the 0.06 times 25. Now, you are to use a graphing calculator, so a TI 80 whatever. So the way you would enter this into your calculator is you would just enter your 40,000 times E, or actually what this is, it's not E, it's second ln. That gets you your E, and it'll have an up arrow. It'll already come out, and it'll have parentheses, and you do 0.06 times 25, close parentheses, and enter. And that'll give you your answer of A equals, and it's 179,267.5628. Now, on my keys, I put as many decimal places typically as it gives me. WebAssign or whatever homework system you're using, typically I think for most of my classes I have WebAssign. It tells you how many decimals. So if you're rounding to the nearest dollar, this will be an 8. You'll round here. If you're rounding to the nearest cents, you'll round here. Now, in the notes, I'll always put out all the decimal places. Okay? Okay, let's go to the next one. All right. So S is invested at 12% compounded continuously. So again, we're using PERT. Done. And it scrolled me up. Comment. All right. So again, we're using PERT. A equals P, E to the RT. So P equals, we're going to invest $1,000. R equals 0.12. And see, this time it gives us our formula. And T or X equals 4. So all we do is S of 4 equals 1,000 E to the 0.12 times 4. Now I'm going to warn you about calculating your, so a lot of students will say, okay, well 0.12 times 4 equals, and then give an answer, and then raise it to the power. I'm going to warn you about doing that, because when students do that, they get rounding error. Your calculator is able to handle putting it all in at one time. So this time what I'm going to do is I'm going to go here, and here is my calculator. 1,000 second e to the x, parentheses, 0.12 times 4, close parentheses, enter. And there is your answer. It is able to handle it. So make sure that you enter it in. So S of 4 is 1616.074402. All right. Now, this concludes the lecture over exponentials. We will pick up on the lecture over logs. Email me if you have any questions.